I'm Anil Kumar. Welcome back to my YouTube channel. The whole month of November, I couldn't make any videos since my left hand was fractured. It'll take about 3 months to fully recover, but I thought I'll get back to the business of making videos. So today I'm going to share with you applications of right angle triangle trigonometry. We'll have 10 questions here. There have been a lot of requests on this topic. You can always pause the video, copy these questions. You can see the very first 5 questions now. They're all based on angle of elevation. We'll also talk about bearing angle. But the common thing here is to solve a right triangle. Here are question number 6, 7, and 8. And then we have 9 and 10, which are application and thinking questions. So I hope you have made a good note of these questions. Try to solve them one by one and then look into my suggestions. So let's begin with the very first one, which is a very simple question based on tan ratio. Question number 1 is, the angle of elevation of the top of the tree from a distance of 40 meters from its foot is 30 degrees. Find the height of the tree. So always what we are going to do is make a sketch, right? So let's say this is the ground, right? Let's say that is the tree. And the angle of elevation is looking upwards. The angle is formed with the horizontal, right? So always elevation and depression, both the angles are with the horizontal. So now what we are given, the angle of elevation to the top of the tree from a distance of 40 meters, so this is 40 meters. Is 30 degrees, so that is 30 degrees. Find the height of the tree, so let's say let it be height. Few basic things which you need to recall is trigonometric ratios. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent, right? So that is what we are going to use in all the right angle triangle examples for this worksheet. So the very first one, tan ratio. Tan is opposite over adjacent. Angle is 30 degrees. Opposite side h, adjacent side 40. Right? So from here we can find what h is by cross multiplication. So we get h equals to 40 times tan of 30 degrees. Now some of you can also use the special triangle at this stage to get the result. So we know this special triangle 30, 60, 90. Very important to remember. So which is 1, 2, square root 3. The angle 30 is right there. Tan is opposite over adjacent, so 1 over square root 3. So the exact answer here for the height will be 40 times tan of 30 degrees, which is from here, this is 30 degrees, right? So 1 over square root 3. And the approximate answer, you will use the calculator. So if the calculator is not allowed, you have to write the exact value, which you'll prefer to write as square root 3 times 4 and denominator will be 3, right? Rationalize and then provide the answer. So anyway, 4 divided by square root 3 is, so do you see that? So that is the actual way you should be writing. And decimal value is 2.3. We'll just take it to one decimal place, right? So 2.3 units. Sorry, this is 40. So it is, 40 times this. So times 10. Let me just do times 10. So that is 23.09. So 23.09. So I'll approximate to 23.1 meters, right? That makes sense. So the height is 23.1 meters. So our answer here is height of the tree is 23.1 meters. Question number 2. The angle of elevation of the top of the tree from the eye level of an observer 1.6 meter tall is 50 degrees. Find the height of the tree if the observer is 60 meters away from the tree. Right? Very similar question, right? With a very critical difference also. This time we are given the height of the observer, right? So, and from the eye level, this angle of elevation is being measured, right? So the situation is kind of like this. Well, the drawing is definitely not to the scale. We have this height as 1.6. So this height is 1.6, right? And the angle of elevation this time is 50 degrees. We need to find the total height. So let's say that this height is A, right? So total height will be A plus 1.6, right? So we are looking for height which is A plus 1.6. So first let us find what A is. Find the height of the tree if the observer is 60 meters away. We know this distance is 60 meters. That should also be 60 meters, right? So we can use the tan ratio. So we have tan of the angle 50 degrees equals to opposite side A over 60, and from here we know A is 60 times tan of 50 degrees. So let's calculate this answer. 60 times tan of 50 degrees, and that is 71.5. Right? So we can now write the height of the tree. Is A plus 1.6, which is 71.5 plus 1.6, right? So let's add 1.6 to this. 73.1. Don't forget to include the units. Question number 2. A lighthouse is 50 meters above the sea level. The angle of depression of a ship sailing towards it changes from 30 degrees to 60 degrees. Find the distance traveled by the ship. Okay, so let's say this is the sea level. The lighthouse is 100 meters above, and the angle changes from, let's say, 30 degrees to 60 degrees. Okay. So we have this as smaller angle of 30 degrees, bigger angle of 60 degrees, and that is 100 meters, correct? Again, tan ratio. Always we are assuming this to be a right triangle. We need to find this times the distance d traveled by the ship, right? Now, let this distance be x. How will you find d? Well, we can again use the tan ratio. We know tan of 30 degrees should be 100 over adjacent side big triangle x plus d. The smaller triangle tan of 60 degrees should be equal to 100 over x. Now we need to find what d is. So we can substitute the value of x and then figure it out, right? So let's cross multiply. So when we cross multiply, we get x times tan 30 degrees. And then we have plus d times tan of 30 degrees equals to 100. And here we have x times tan of 60 degrees is equal to 100. To get the value of d, we have to eliminate x. So what we'll do here is we'll just substitute the value of x from here to this place, right? Let's calculate this value of x. So x is equal to 100 over tan of 60. Let's calculate this. 100 divided by tan of 60 degrees is equal to 57.735. Substituting here, we can get the value of d, right? So let us isolate d first. So we can say d tan 30 degrees is equal to 100 minus x tan 30 degrees, and so d is equals to 100 minus x we write as 57.735 of tan of 30 degrees divided by tan of 30 degrees. Is that clear to you, right? So let's use calculator to find this. So we have 100 minus 57.735 times tan 30 degrees. And then we are going to divide this by tan of 30 degrees. That gives you 115.47. So the distance d traveled during this time is, so therefore the answer is distance is 115.47 and the units are in meters. So I hope the steps are absolutely clear. Question number 4. A ladder inclined at an angle of 60 degrees to the horizontal reaches 6 meters short of top of a tree. Find the length of the ladder if the tree is 10 meters high. Okay. So let's sketch. So we have a tree right there and a ladder which is trying to reach, well, 3 meters short. So this is 3 meters. Total height of the tree is 10 meters, right? So this is 7, right? 7 plus 3 is 10. We know that the angle of inclination in this case is 60 degrees. We need to find the length of the ladder. Correct? So now we are interested in opposite and hypotenuse. So the sine ratio, right? Sine is opposite over hypotenuse. Correct? So we'll use sine of 60 degrees equals to 7 over L. So L is equals to 7 over sine of 60 degrees. So you can always use special triangles, but we'll use calculator to figure this out for now. So sine of 60 degrees, which in decimals is 8.08. So we'll write this as around 8.1 meters, right? Perfect. So that is how we are going to solve it. Question number 5. The angle of elevation of the top of a tree from points A and B are 60 degrees and 40 degrees respectively. Find the height of the tree if the distance AB is 6 meters. Assume A and B on the same side of the tree. So in the ship case, we found the distance. Now we are given the distance between points A and B. We have to find the height, right? So it's very similar. So let's make this diagram once again, similar to what we had done earlier. The angle of elevation to the top of the tree from A and B is 60 degrees and 40 degrees. Find the height of the tree if A to B distance is 6. So this is 6. We don't know what this is. We'll put this as x. Is that clear to you? Okay. Now again, we're interested in opposite and adjacent. We are going to use tan ratio. So we know tan of 60 degrees is equal to height over x. And tan of 40 degrees is what? Height over 6 plus x. We need to find the height, right? So to find the height, we can just isolate and then figure out the answer. Correct. So let's calculate what x is in terms of. So from here, we get x tan 60 equals to h, right? So which is x equals to h over tan 60. Let's calculate. So 1 divided by tan 60 is square root 3 over 3. Let's take the decimal value. 0.577. And in this case, we get 6 plus x equals to h over tan of 40. So that is 1 divided by tan 40, which is 1.19, let's say 17 h. So we got these two equations. We can take one from the other. So subtracting one from this is times h. So let's call this as our equation number 1, this as equation number 2. And if I do equation 2 minus equation 1, we can get the value of h, right? So we get 6 equals to h times 1.1917 minus 0.577, right? So the value of h is 6 over 1.1917 minus 0.577. So 6 divided by, within brackets, 1.1917 minus 0.577. So 9.76 meters. So that is the height. So we get our answer. Height is 9.76 meters. Right, so we have almost done 5 questions, halfway. Now let's take question number 6. The angle of elevation of the top of a building from the top and bottom of a tree is 20 degrees and 60 degrees respectively. Find the height of the building if the tree is 12 meters high. Okay, so let us say these two things are right there. We have a big building here and we have a tree. Okay, so height of the tree is given to us as 12 units, right? So this will be 12. The angle of elevation from the top and from the bottom is also given to us, right? So this angle here from the bottom is 60 degrees and there we have 20 degrees. We need to find the height of the building. So it is in two parts. Let's call this as A, and we'll add 12 to get the total height. We are given this 12 is the height of the tree. Now let's find the distance between the two using tan ratio first. So we can say tan of 20 degrees is equal to, this will also be x, right? A over x. And tan of 60 degrees will be a plus 12 over x. Now, since we are interested in finding a, we can divide one equation by the other, right? So we can say tan of 60 degrees over tan of 20 degrees is equal to a plus 12 over a, right? Now, so from here, we can just cross multiply, rearrange, and get our answer, right? Okay, so, or we could take away 1 from each side and then also do it, right? So there are different techniques to work with. Let's just cross multiply and do. So cross multiply, we get a tan of 60 degrees equals to a tan of 20 degrees plus 12 tan 20. Right. So we can isolate a. So we get a tan of 60 degrees minus a tan of 20 degrees is equal to 12 tan of 20 degrees. And from here, take a tan 60 minus tan 20 equals to 12 tan 20, correct? So do you see a formula being generated right there? That's a very important formula. We can actually use this kind of a relation, and many times in multiple choice questions, you may just be given angles x and y, and we may have to find the relation, right? So from here, we can say what a is, right? So we can say a is equal to 12 tan 20 degrees divided by tan of 60 degrees minus tan of 20 degrees, correct? So let's calculate this value. 12 tan 20 degrees divided by, within brackets, tan of 60 minus tan of 20 is equal to 3.19. So the total height of the building will be a plus 12. So it will be 3.19 plus 12 or 15.19. So you can approximately say 15.2 meters. Is that clear to you? So that is how you could actually solve this question. Have a good look at it. Let's move on and take question number 7 now. The angle of elevation of top of a building from the foot of a tower is 30 degrees. The angle of elevation of the tower is 60 degrees from the foot of the building, right? If the tower is 40 meter high, find the height of the building. So it's slightly different from what we just did. So we again have two things. So the angle of elevation, we have two things. So we have a tower, okay, and a building. So we're talking about angle of elevation from both. Okay. So let me use different colors. So it says the angle of elevation of top of the building from foot of the tower is 30 degrees. And the angle of elevation of the tower is 60 degrees. If the tower is 40 meters, so this is 40 meters, find the height of the building, let's say h. So that is the question for you, right? Now, let's say the distance, let's say this is t and this is b. So let's say the distance t to b is x. Now again, we can use tan ratio, right? So we get tan of 60 degrees is 40 over x, right? On the other hand, we have tan of 30 degrees is h over x. Well, since we need to find the height of the building, we can just cancel x, right? So let's say this is our equation number 1, this is equation number 2, right? So if I divide equation 1, let's say because h is here, let me divide equation 2 by equation 1. Okay. So what do we get? We get tan of 30 degrees over tan of 60 degrees is equal to h over 40. So h is equals to 40 times tan of 30 degrees over tan of 60 degrees, right? So that is how we can figure this out. So 40 times tan 30 degrees divided by tan of 60 degrees is 13.33, 13 1 over 3 meters. So that is how you're going to solve this, right? We are almost at the end. Question number 8, 9, and 10, right? Question number 8. The angle of elevation to the top of a tower is 32 degrees from a point A due south of it. The angle of elevation to the top of the tower from another point B due west of the tower is 40 degrees. Find the height of the tower if the distance AB is 45 meters. So we are now talking about something in 3D, right? So whenever you have a situation like this, I'll prefer to sketch X and Y kind of like this. Do you see that? So that gives you a 3D effect. And the vertical side, X, Y, and Z, right? So we have this representing the height. Now that makes things clear, right? So we have X and Y along this paper, think like this, right? And now we'll make a sketch. We'll say this is our north, right? Oh, sorry. And that is south. So this is east and that is west. So what we are given here is that the angle of elevation to the top of the tower is 32 degrees from a point A due south. So somewhere here, right? So let's say something like this. So the point A is due south and that is the top T. And this angle, that is 90 degrees. Do you see that? This is 32 degrees. That is how you're going to sketch it. Let the height be h, which you need to figure out. So in this particular triangle, you can say that tan of 32 is height over, we don't know what this distance is. Let's say O to A, right? So we'll say OA. Now, it says that the angle of elevation to the top of the tower from another point B due west of the tower is 40 degrees. So on the other side, due west, let's say that is the case, right? And this is 40 degrees. So O2, let's call this point B, right? So we have tan of 40 degrees is h over OB. Now we are given the distance between A to B also. So let's mark that distance. We know this distance AB is given to us as 45. Right? So this is the distance between south and west. So there is a 90 degrees angle between these two. Do you realize that part, right? Okay. Now, what we have here is two relations relating the sides A and B which are at right angles. Okay, so this is actually at right angles, right? So this is at right angles. So that angle is 90 degrees. Doesn't look like, but it is 90 degrees, right? So these two squares will be equal to AB square. Remember that. Okay. So let's find what OA and OB is. So from here we get OA equals to h over tan of 32 and OB is h over tan of 40 degrees. Correct? And since we know that distance between these 2 points is 45 and that is right angle, it doesn't look like, but it is. So we know that AB square is OA square plus OB square. Perfect. And therefore, what we have here is that 45 square is equal to sum of these two squares. Correct? So, is equal to h over tan 32 square plus h over tan 40 square. Is that clear to you? So let's find that answer, right? So what I will do here is rewrite this as 45 square equals to 2025. So it's just 2025 is equal to h square 1 over 32 square we have to do, right? So we'll do 1 divided by tan 32 and we'll square this. What we get is 2.56 61 h square plus here we have 1 over tan 40 square, so 1 divided by tan 40 square is equal to 1.42 h square. Is that clear, right? So what I did was 1 over tan 32. So it is like this, within brackets 1 divided by tan 32, right? And then we need to square this. 2.561, that is the coefficient of h square, right? So we get this part. Now we can add these two. 1.42 and what we get is 3.981. h square is 2025. Perfect. So from here we know height is 2025 divided by 3.981 square root, right? So we'll divide 2025 by 3.981 and we'll do square root of our answer. 22.55. So that is how we are going to get the height. Is that clear to you? Right? So I'd like you to go through these calculations, understand what we did. Remember, we are talking about 2 points which are on south and west. So the angle between them is 90 degrees. If you want, you can separately draw it, the base, right? So you can make 3 different diagrams to solve also, right? And then do it. So basically, this portion is kind of like this. Do you see that? It's kind of like this, where we have O, B, and A. That is, this is south, right? And this is west. So there's 90 degrees angle here. Perfect. So that is your on the paper, right? And so from here we can use the Pythagorean theorem to relate these. So I hope the concept is absolutely clear. we get the height as 22.55 meters in this particular case. Let's move on and take the second last question, question number 9. A ship sails 25 kilometers from A at a bearing of 36 degrees to reach B. Then it moves to port C 45 kilometers away at a bearing of 090 degrees. What is the distance and bearing of C from A? I would like you to pause the video, sketch this diagram, and then look into my solution, right? Okay, when we say bearing angle, it is clockwise from north, right? So let's try to sketch the diagram first. So this is north for us. A ship sails 25 kilometers from A at a bearing of 36 degrees to reach B. So we'll assume A to be at the origin itself. Bearing of 36, that means this angle here is 36 degrees, right? So let's say the ship moves like this and reaches the point B. Then it moves to port C, 45 kilometers away at a bearing of 90 degrees. This distance is 25 in kilometers. Now, when you say bearing of 90 degrees, it means what? So at this point B, look from here 90 degrees. So it has to move in this direction. Do you see that part? And it moves in this direction, which is east 45 kilometers. Let's say to this point. So that becomes your point C. What is the distance and bearing of C from A? Now, once we have a neat diagram, we can actually figure out the answer easily. So we want to find this bearing. Means we need to find that angle. That is the question for us. Correct? Now let's solve it. We know this angle here is 36 degrees. Now, how do we solve this? We know this length is 25, the angle is 36, so we can find this point. Let's call this point as P. So we can find what A to P is. So A to P will be what? Well, we know this is the adjacent side, that is the hypotenuse, so cos of 36 can be utilized, correct? So A to P over A to B is cos of 36 degrees. So AP is 25 times cos of 36 degrees, correct? So let's figure this out. So we have 25 times cos of 36 degrees, which is 20.225. So we know AP is 20.225. Okay. We can find what PB is using sine, right? So P to B will be equal to 25 sine of 36. So let's find this out, right? That is the sine component. 25 sine of 36 degrees. 14.694. So we know P to B. Now that is the right angle because it has moved east, right? We know that B to C is 45 kilometers. So this is 45. We know P to B. Now we can easily find the angle, correct? So you could think like this. Let's call this point as D. Now if you look, or you can just see from here, you can find this angle C using tan ratio, right? So we can say tan of C, this angle, tan of C, is equal to PA over PC. Now PA or AP is 20.225 and P to C is 14.694 plus 45. So we get what tan C is. Let's figure this out. So we have 20.225 divided by, within brackets, 14.694 plus 45. And that is equal to 0.3388. So if I do tan inverse, I get the angle C, right? So the angle C is equals to tan inverse of 0.3388, which is, so we'll do shift tan inverse of our answer, and that is 18.716. We can write this as 18.7 degrees. Correct. So the angle here at C is 18.7 degrees. Now, once you know that angle C, we can find the bearing angle. So if you look into it, this is 18.7, right, this angle? So that is the bearing angle. So what is the distance and the bearing of C from A, right? So from A, we have to see the distance and bearing. Distance you can find using the Pythagorean theorem. This square plus PC square plus PA square, we can get 8C squared, right? And the angle which we are talking about is the same as this angle, which is 90 minus 18.7. So the bearing is 90 minus, let's say 090 minus 18.7 degrees, right? So that is, so we have 90 minus 18.7, and that gives us, in decimals, 71.3. So when we are writing bearing angle, we have to write with 3 digits, right? So the bearing angle 0713. So the answer here is bearing angle is 071.3 degrees. Correct. One, we need to also find the distance A to C. So let's figure this out. Distance A to C. AC square, or we can say AC directly, as PA square, which is, let me write, PA square plus PC square, square root, right, using Pythagorean theorem. So, which is square root of 20.225 square plus P to C, we have to add 45 to this. So adding 45, we get 59.694 square root. So let's calculate this answer. So square root of 20.225 square plus 59.694 square, which is equal to 63 approximate, right, meters. So the bearing is this much and the distance is 63 meters. Is that clear to you? Perfect. So that is how we are going to answer this question. So I hope the steps are absolutely clear. Now let's take the last example. Let us see how to solve this question. A ship sails 60 kilometers from A at a bearing of 130 degrees. Then further 150 kilometers on a bearing of 220 degrees. And then returns directly to the starting point. Find the length and the bearing of return journey. You can always pause the video, answer this question, and then look into my suggestions. So here is a diagram to work out the solution. When we say 60 kilometers at a bearing of 130, that means the angle from here is 90 plus 40, right? So that becomes the angle. So this angle is 130 degrees. That means 90 plus this angle here is 40 degrees, correct? Further, 150 kilometers on a bearing of 220. So at this point, we have to go for a bearing of 220. 220 means 50 less than 270, right? So kind of like this, and much kind of like this, right? So that becomes the case. So this is 220 for us, and this angle here is 220. Sorry, this is 150 kilometers, sorry. 150 kilometers. The other one here was 60 kilometers. Okay. Now, we have to figure out how will this return, right? So it has to return to the starting point. That's the diagram. Let's call this point as A. Now this is B for us, and that is C. Okay. Let's see the angles. So if this is 40, this angle here will also be 40. When we are saying 220, then it is 50 here, right? Now 40 plus 50 is 90 degrees, so we have a 90 degree diagram. So that means A to C basically is, since we have a right triangle, we can find this as square root of 60 square plus 150 square, correct? Since the triangle ABC is right triangle, correct? So let's find this first. So we have square root of 60 square plus 150 square, which in decimal is 161.55. The units are kilometers. So the ship has to return 161.55 kilometers. Now we need to find the bearing angle. Okay. Right, so we need to find this angle. Since this is a right angle, we can use tan ratio to find this angle, angle C. So we can say tan C is equal to 60 over 150. That means angle C is equal to tan inverse of 60 over 150, correct? So we have shift tan inverse 60 divided by 150, which is 21.8. So this is 21.8. Now we can find the third angle, which is angle CAB, right? So angle CAB should be 180 degrees minus 90 degrees minus this 21.8 degrees, correct? So let's do 90 minus 21.8. So in decimals it is 68.2 degrees, 68.2 degrees. So this total angle is 68.2 degrees. Now we know that the angle the smaller angle here should be how much? 68.2 minus 50, right? So we have this combination. So let's take this point as let's say P, right? So the angle CAP will be equal to 68.2 minus 40 degrees. So we get 28.2 degrees, correct? So that is the vertically opposite angle right there. And so we have this angle as 28.2 degrees. And therefore, bearing angle for return is 028.2 degrees, correct? And we already found the distance as 161. Distance is 161.55 kilometers. So I hope with this you understand how to solve such questions. Well, in this series we have solved 10 questions, all based on right triangle, and we have learned strategies. How to start with simple tan and sine ratios, apply some concepts for bearing and angle of elevations, and also take up questions like a 3D questions which we did in question number 9 and 10. So with that we end our worksheet on right triangle applications. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.